actually the electronics and the antenna are on one U panels. The antenna on one side and the electronics on the back. And one U digital processing board, so basically it takes almost no space inside the CubeSat. It's a software-defined radio design. The digital board is, of course, doing the processing. And we have 2 watts RF, about 10 watts maximum during transmission at long distance, which is much less at shorter distances. And the board can do other tasks, which is interesting. So, CADR means absolute CubeSat, active debris removal experiments. Need also a collision alarm for close range distance measurement or distance evaluation. So we've shown that there are COTS modules in the 24 gigahertz ISM bands. No, I pronounced the word ISM. We will change them to 23 gigahertz to fit in the spaceband. They are very small, they are very low power, and they're actually cheap, so we can put plenty of them on the satellite. So, frequency bands. For the long range, in the X band, we don't have any frequency band yet. It's primary radar, which is a new subject in space, or very new. And existing systems have secondary radar, meaning the target is actually sending a signal. Or there is a roundabout system, so like a 1D GPS. But we have only, for passive targets, it's only Earth space or space Earth. There's no space for the moment. So we have to do it in 2 phases. At the short term, before end of 2015, I need a frequency. We need a frequency to design the device. So frequency band. So in the 7 to 14.5 gigahertz range, ideally at 300 megahertz wide, but we could do with 100 megahertz. Okay, SRR, I think it's less a problem for short range. Can it be done on an extension of currently defined services, or can it be under space research? Still, that must be still open. And it would be a working party 7C subject, because it's about sensing. And at long term, I think we have to define a new service, which is space radio navigation in X, KU, and KE bands, because, well, we have to make the space radar exist officially. So, there are the definitions: radio determination, radio navigation, and radio location. Again, there is no space versions of the above. It's space to Earth, possibly Earth to space, but not. 51 service in the Arctic 5 of ITUR, I don't know, but somehow it must be defined. So we done with the Swiss Ofcom, which back home, we've done some preliminary work to identify bands. Basically 3 bands, taking account only technical and ITURR, and considering only LEO. So basically there is at 9, 14, and not C band. 5 gigahertz is too narrow and too large wavelength. So basically there is a band in X band, which is a traditional radar band, even a maritime radar. So there are a lot of clauses and a very threatening one, which seems to exclude primary radar in this band. So we have to sort that out. Then there is the KU band, a long-range radar variant of this one would be from 14, just above 14 gigahertz. looks a bit better, but there is the VSS service, which is primary, so it has to be okay. And SRR, it's not a problem because it's very low power, and there would be no interference to Earth because there is absorption in this band in the atmosphere. So, what would be the outlook for space radar? First, an evaluation of the interference to other services. It's very necessary, but it must take into account the typical CubeSat antenna, low gain and small size, low directivity. Fixed antenna orientation during operation, because there is obligatory attitude control on the satellite. And taking account, of course, Earth power and the bands I have already mentioned. It should mention Earth orbit as well as deep space. Beyond X-band, K-band could be the next option, but again, it needs beamforming. It's more complex, but it's definitely the next subject. Needless to say, radar can be a radio, so both functions could be done by the same device, just changing the software, because now we can change the flight software, so it could be the same device. So beyond just one debris experiment, we could imagine having a radar payload on many satellites, because it's just a small device which doesn't take much power and much space in the satellite. Would be oriented, it would be for monitoring of passing by debris, like a cartographic device, and beam oriented upwards to avoid terrestrial interference. And of course, this needs its own radar band. Almost finished. And then there is deep space and asteroid approach and radar as a navigation device. That's a future subject. And who you are, a group of professional engineers doing microwave, Internet of Things, biomedical. And we love to do things that really work and that fly, that go into the body also. And it's a hands-on business approach. We have close contact with industry partners, and there are 4.2 radio amateurs in the group. The 0.2 is myself. I don't have the license anymore, but I'm thinking about having it again. Yes. So I will not go on this one, and I'm finished.
Thank you very much. Quick question. Okay, quick question. One. This will be the time during Norbert can load his. Sorry.
Well, first of all, thank you for your presentation, and I think it's a nice mission in order to detect the location of the space debris. So I mean, in terms of the mission. However, I still some questions and difficulties with your research concerning the frequency band. We may discuss that offline, but for instance, at 9 GHz, this is a synthetic aperture radar band, ESS active. It is not dedicated to observe at the horizontal, but to observe download. So there may be compatibility problem. And second issue, you are looking for a band close to 24 GHz. Okay, you said that there are no difficulties because the atmospheric attenuation is high. It is not true. It is only a few dB, and you are close to a passive band. So there are unwanted emissions problem. And so there are, I think, well, your mission is very good, but you are facing, I think, very serious difficulties in terms of frequency bands.
Absolutely.
And maybe we should think twice, probably. Thank you very much.
Thank you. I think the first step which I recommend to you to visit Ofcom and write to us with a request for assistance as to do it formally, that we can have a look and see on it, not only based on your presentation, but really with the Ofcom as a request for assistance. I thank you very much again. You received just from our assistants symposium evaluation form. It's anonymous, free of charge, and you don't have to pay nothing. And when you will leave the room, we are kindly asking you, or leave it on your desk or put it to the box. It will help to us to understand if we are going to a good direction, to continue with such activities, symposiums, or with the small satellite community, or to change it, modify. That's why we thank in advance. Now, we have a presenter, Norbert FRISCHAUF, Director of European Space Operation, SpaceTecPartners. Norbert finished high energy physics. He's not a satellite engineer by origin, and that's why he decided to go to the best place on the world, not to ESA, not to space, but to CERN, to break the atoms. But it seems that he was not happy with the breaking of the atoms and quarks and others. That's why he decided to go to ESA to help ESA with the ATV and other challenging projects. And now, after then, he was managing director of Kasar Technologies in Vienna. And now I understand that he is running a SpaceTecPartners project, and he's going to present to us some extreme challenges which can be done with the small satellite. Norbert, microphone is yours.
Thank you, Attila. Good afternoon. I hope this piece works. Yes. So yeah, you might seem a bit of jack of all trades, and we just look over here. Austrian Space Forum. We're working in the QB50, for example. Not me personally, but colleagues of mine. Alpha Austria means that I'm a TV journalist in Austria, Swiss and German TV. And SDP, SpaceTecPartners, which is a company working in space applications area mostly, together with lots of others. So it means Earth observation and things like that. And I'm also an aerospace expert to the Austrian Armed Forces. And that's the reason I'm talking about a bit of satellite space and security, so to say what the military is thinking about these things. A little bit of background, so to say, also from the history, but also forecast what could come and whether there's a match with small satellites, yes or no. But all the stuff that is presented here is not really secret in a sense. You can all find it on the web. Now, maybe if you know, of course, about observation, reconnaissance, and all those different things, but we came really into the mindset of the public with these pictures here. Of course, after September 11, there was a 3-day ban of all activities, aerial activities over the United States. So the only pictures we saw from ground zero at that time were really coming from satellites. In that sense, it was the Iconos satellite. Already with a resolution of 1 meter, we're talking about the year 2001, which means you could easily see the cars traveling here on the street. It went a bit better with years to come. This, of course, is the launch pad of the space shuttle, if you look into it. And if you just look here to the side, on the other side, QuickBird, 2005, resolution of 60 centimeters. You can easily catch out what kind of cars these are. So it opens up a bit of a privacy issue, because at a certain point you can ask who came to work this day or not. But believe it or not, joke aside, so to say, space has always been a role of sort of battle space a bit, what has been done in the military field. Of course, there's always been science and reconnaissance in that sense, but it's always been, of course, used in navigation, space reconnaissance, especially for intercontinental ballistic missiles, control of your own rockets, and of course, looking what the others are doing. Communication purposes, still a hot topic, and of course, SDI, which was a kind of an interesting thing in its own. The whole presentation would last usually 45 minutes to 60 minutes, so I shorted it down, and therefore, I will not cover that point really here. Interesting is that space is now an integral part of the US defense doctrine. So it's really, really high up in that one. It's part of the strategic command. Domination is a clear ambition in that sense. And the roles that have really changed. It's still used for guided missiles control.